Hey everyone, Kumar here. And today's topic is active learning versus design of experiments. This is a question that we get constantly, and it's a very valid question. What makes better sense? What's more accurate? Is active learning better than design of experiments? Is design of experiments better? In what situations? All of these things we will discuss today in this video. So, question is, who wins? So before we get to that, let's start with a basic description of what's going on here. Active learning offers an adaptive, data-efficient learning system. It's ideal for costly, high-dimensional formulation problems. And what it does is it builds a probabilistic model that continuously learns from results and then figures out or prioritizes promising regions of the space that you're looking for. Design of experiments is different. What it does is it predefines all the experiments that you will do in a very deterministic space-filling manner. So you have a search space, and you want to figure out a set of experiments that covers the entire space so that you can build an understanding of that entire system and then use that to predict future outcomes for future ideas. From a scientific point of view, active learning, what it's doing is it's maximizing information gain per experiment. So you're not just about creating a bunch of data from running several experiments, but you're trying to figure out what is the maximum amount of information, which is different from data, that can you gain per experiment. So the least amount of iterations, the fewer number of experiments, how do you converge to the ideal formulation with the minimum required investment? And it's extremely valuable when the entire process is very expensive. There are trade-offs that you have to make, or you have a lot of constraints. Real-world constraints could be nutritional, factory, manufacturing, regulatory that you have to deal with. In those situations where experimentation is very expensive, or you're in a multi-dimensional space, using active learning reduces the effort required to get to the right answer. And we see this benefit play out in real-world partnerships when teams shift from doing design of experiments static approach to active learning, which is more responsive and it's a more real-time strategy, real-time learning strategy. So what does active learning versus design of experiments really mean? This is one of the things that we do want to talk about a lot is there's no way to guarantee that active learning delivers faster and better results in every case. However, if you do it enough, if you do sufficient campaigns of active learning with multiple experiments, you're more likely across all of these attempts to find that active learning is much better than design of experiments. So on any single instance, single experiment or campaign, we cannot guarantee it. But in average, overall, you tend to spend less time, money, and effort running multiple campaigns across multiple initiatives and learning faster using active learning. There is a strong statistical practical argument for when active learning typically outperforms design of experiments, especially in modern formulation and R&D problems. So let's take a look at, kind of break it down, design of experiments versus a guided exploration engine, which is what active learning is. So the philosophy is for design of experiments is that you pre-plan all the experiments that you will do in a structured manner. So it's a structured exploration, and it requires the understanding of the entire search space upfront, and you design your experiments to do that. Guided exploration engines, on the other hand, are adaptive, learning-based search, meaning that you start out, you do some experiments, you learn from it, and then you adjust your strategy for the next batch of experiments based on what you've learned. So you're not committing, or you're not saying that we will do all possible experiments upfront. We're doing in smaller batches, and we learn from them. So on design of experiments, you might have a fixed grid or a fractional design that you create before any of the results are known. Whereas in active learning, you're choosing the next set of recipes based on the results from the previous trial. And what the goal typically for the exploration strategy in design of experiments will be to, trying to cover the design space uniformly. Whereas in active learning, you're trying to focus on promising regions while avoiding the poor ones. And that's very intelligent, because if you know something is not going to work, there's no point wasting time and effort understanding that area better. You'd rather focus on things that you might not know much about, but are likely to be better. And that's where you focus all your time and energy on. And so, on design of experiments, you might do one-shot or batch runs, whereas guided exploration is all sequential or batched, but you're continuously refining based on what you're learning. And what that means is that typically design of experiments will require more experiments to map the space. And the real benefit of a guided exploration engine that uses active learning is that you're learning from fewer data points. And so you often converge faster to what you're looking for. Design of experiments is also hard to change midstream, right? You have to go figure out all your entire set of experiments up front and then execute them. You cannot change them because that changes your design of experiment strategy, which means that you have to redo the entire process again. Whereas a guided exploration engine will naturally support replanning and constraints. From a modeling perspective, you're really using linear models on design of experiments, whereas on a guided exploration engine, you're using probabilistic surrogate models like Gaussian processes to model uncertainty and predict outcomes. What that means is that design of experiments will not adapt if many recipes fail or underperform, whereas a guided exploration engine will learn from the failures to avoid similar regions in subsequent experiments. And there's a space for design of experiments. It works well when the factors and ranges are well understood and the interactions are simple for what you're trying to understand. But when your space is complex, high dimensional, expensive, or extremely constrained, that's where you want to, where it's actually physically, oftentimes it can be impossible to run design of experiments. This is where you want to find something that goes after the promising regions, avoids the known bad, and converges as fast as possible, because a complex space in a typical design of experiments manner would be very expensive to completely map out that space. And so you want to do it using active learning. So here's an analogy. Design of experiments is like surveying a city with a grid of drones. You fly them in a pattern, whether or not the area is interesting. So you basically say, I'm going to go and I'm going to survey the entire grid, the city, using a grid, and you will go and it doesn't really matter whether you want to map that area or not. You will go and spend the time and money to go map it. Active learning is more like sending a smart drone that is constantly looking at what's happening, what it's seeing, what information is coming in, and then it's updating its flight plan based on where it finds treasure or dead ends. So it gets smarter with every flight. So it's not just about going to all possible areas in the city. It's updating itself based on where it's finding treasure or where it hasn't explored and it has no information about whether there's treasure or not, but there's high chances of potentially there being treasure, and it adapts its flight plan to go explore where the outcomes that it's looking for are likely to occur with high probability. So let's talk about why and when active learning typically outperforms design of experiments. Active learning uses a probabilistic model. It builds a surrogate model that captures both the expected performance and the uncertainty of unexplored regions. So it allows active learning to make intelligent trade-offs between exploration and exploitation, and you're prioritizing the experiments that are most likely to improve the outcome. Active learning is sequential and adaptive. Design of experiments is static. The experimental plan is locked before you run any experiments and any data is generated. Active learning will learn from every data point. It's going to update its beliefs and then based on that, refine the search space. This leads to fewer wasted experiments, which are going and looking at unpromising regions that are typically not where you want to spend your time and money experimenting in. Active learning is also statistically more efficient in high dimensional or constrained problems. And there are a lot of empirical studies that show that any place where you have more than 4 to 5 variables, design of experiments quickly becomes inefficient. Active learning scales better, avoids the combinatorial explosion that you see with design of experiments, by leveraging structure and uncertainty modeling. And in the real world R&D, constraints matter. Design of experiments cannot easily handle non-linear constraints. And active learning, uh, in comparison, can model feasibility directly and avoid proposing invalid experiments. So here's a case study, infant formula reformulation. The challenge was, for the nutrition team to reformulate an infant formula to match a new regional regulation, optimizing for protein, digestibility, and sensory profile. For design of experiments, you had to create 27 recipes upfront with a full factorial design across 3 ingredients and 3 levels. The team found few viable options and had to run another full round to reach a satisfactory recipe. So 54 experiments in total. In a parallel stream, if you applied active learning with prior knowledge, existing formula data, after just 12 recipes, active learning was able to figure out the high-performing regions, and by recipe number 70, the team had a viable formula that met all targets. So what's the outcome? 70% reduction in experiments, faster decision-making, and real-time trade-off navigation. Another example is of a plant-based creamer stability. So the team needed to optimize emulsion stability, mouthfeel, and whiteness of a plant-based creamer, balancing 8 ingredients and 3 process variables. A fractional factorial design with design of experiments required 32 runs to explore interactions. However, instability in many samples led to unusable data and gaps in the response surface. Then they tried active learning. It began with 5 initial recipes and iteratively adjusted based on stability and sensory feedback. It learned to avoid failure regions, and within 15 recipes, found stable formulations with optimal texture. Outcome, faster conversions to success, lower wastage, and higher trust from the R&D team in adaptive experimentation. There's quite a bit of scientific evidence and benchmarks that also helps towards this or supports this conclusion. There are several peer-reviewed studies and industry reports that support active learning's superior efficiency. As a couple of examples, it's also become the default in auto machine learning systems, auto ML systems, Google, Facebook, Microsoft. They're replacing grid random design of experiment style search due to its sample efficiency. You need less experiments to get the results that you're looking for. And in other domains like pharma and material science, it's already being used extensively to minimize costly wet lab runs by prioritizing only promising experiments. Now, there are instances when active learning might not perform design of experiments, right? There are some examples of that when the problem is low dimensional. So you're only worried about 2 or 3 variables, and the space can be exhaustively covered. Where you have very little prior data, so you have 0 data. There's no smoothness in the objective function. It's very noisy or discontinuous. Or when you need to pre-commit all experiments up front for whatever reason, regulatory or logistical reasons. When any of these or all of these are true, then maybe design of experiments will work. But if it's if you're talking about high dimensional spaces, you have some data, some prior knowledge, and you're not able to commit to experiments, or your QA capacity is limited, then active learning is the right strategy to leverage. So, final point, active learning maximizes ROI per experiment. And this is key. You want to keep this in mind. You want to maximize your ROI per experiment. So while you cannot guarantee better results in every scenario, you can say that active learning will maximize the value of every experiment. And in complex real-world formulation tasks, it will typically lead to faster convergence, lower costs, and better solutions than fixed design of experiments approaches. So hope that helps to understand when to apply design of experiments and when to apply active learning. And we're here to answer any other questions. Reach out and we'd love to chat. Thank you.